So here we go. Recording is going. So welcome everybody. Today is Saturday, April 9th. And this is DPRG's monthly meeting. And today we'll have Jesse Brockmann give a presentation on his Oak-D-Lite implementation, hopefully contest winning kind of a thing. Briefly about DPRG for those who aren't aware or watching this video offline. Been around since '84, 501c kind of educational focused organization. We meet every Tuesday night virtually since COVID, and generally the second Saturday of every month. And we mess around with robots and coding and microelectronics and fabrication and things related to that, mechatronics. A shout out of thanks to our various sponsors, people who have helped keep the club going, support the costs over the years. If you're not aware of it, there is a Robotics Chat Discord server. We had Murray from New Zealand for a few years, very active, and he started this Discord, which continues to be very active. So it's a good, if you're familiar with Discord, it's a good way to be involved and interact with the almost 100 or so people, I think. We're still pending some formal actions for the club with regards to a new slate of officers. Until then, we just have interim stuff going on. Moving forward after this month, there's discussion of is it June or July competition, Doug?
Right now, it's tentatively in for the second week of June.
Second week of June, okay. So that's, well, just stay tuned to the D-list on that or join in.
Yeah, this next week I'll have something out there on it. The one for sure contest that we'll have there that's available for people remotely as well as locally will be the Foursquares contest. And for that you need probably a space of 10 by 10. So if you can find a flat place with a 10 by 10, you can compete. And it's essentially you go around the square and you have to end up exactly where you started, and you measure the distance between it, and that's your number. The best of three is your final entry, and it'll compare with all of the others. We'll have we'll have local prizes and we'll have non-local prizes. Non-local, I don't know what the right word for it is. So we're expecting people from places like Canada and whatnot that can't be here to go ahead and participate, and everybody is welcome. It's a good check of your robots, mechanical construction, and it's a pretty basic one. There may be other contests, but right now that one's for sure.
Doug, this is Donna with the SRS.
Yes.
So is that 10 by 10?
Well, I think
feet that you're talking about?
Yes.
Feet? Okay.
I'm pretty sure.
And what was the?
Go ahead.
Go ahead. Oh, I was just then the other question I had on that is what was the planned date for that contest event?
Right now it's the second week of June. Saturday, second Saturday of June. I'm sorry.
That would be that would be the 11th.
Yeah, and so what we're talking about, Donna, I think if you look at contest rules, the square can be as small as 8 feet and up to 13 feet. Okay, now obviously you need some room for your robot to go around it. So I was trying to give you a lot of people have a room that's 10 by 10. They should be able to run it in that without too much trouble.
Okay, so we are talking, can we choose either an indoor or an outdoor space for that?
Yeah, but the smoother the surface, probably the better your results will be.
Okay.
I'm just saying.
Yeah.
It's not required though. I mean, outdoor would work. We've done it outdoors. But you probably don't want a whole bunch of concrete seams and bumps,
Right.
Don't do it on a cobblestone,
Okay, right, yeah. Right. Or on a blacktop surface.
That'd be fine. That blacktop probably worked great.
Yeah. Okay. Great. Thank you. Thank you
Okay.
for the info.
Watch the communication. There'll be more on that. And I think unless there's any other items, there's just a general wish list. I won't go through them all of things people wanted to see or have offered to present. So if ideas come up, just send them our way and we'll add it to the list and keep an eye out. But meanwhile, we'd like to thank Jesse for reaching out and offering to give a presentation. And I've seen a preview of this, and it's pretty cool what you've got, Jesse. So I know everyone's going to be really impressed and excited to see what you've got. So without further ado, Jesse, take it away.
All right, just a second. Let me get a window shared. My slide should be coming up.
Yep. There it is.
So Ted and I are involved with the contest. It was called Spatial AI by OpenCV. OpenCV, if you're not aware, stands for Open Computer Vision. It's a library that you can download, and it's also a company. And they also do weekly webinars, and so I'm actually going to be presenting a similar meeting to this next week on Thursday. So if you want to join me on that, that'd be great. So the Spatial AI Contest was to use a Legos and an Oak-D to replicate a real-world scenario in the area of AI manufacturing. So they're giving out a total of $45,000 worth of prizes. Each team of the 50 picked to compete got an Oak-D-Lite per team member, so you could get up to 3, a gift card to purchase your Legos, 500 hours of Microsoft Azure training on higher-end hardware, access to the Intel Developers Cloud, and access to Discord server for discussions. Then the final prize, the big prize, is $5,000. Second is $2,500, and third is $1,000. And you also could win a trip to Microsoft Build, which takes place every year, to present your presentation. Unfortunately, Build has gone virtual this year, so instead they're giving you a professional edited version of your video to be presented, and other prizes that they haven't shared with us yet. So I'll find out on April 21st who won, etc. So our intended idea was to build an autonomous rover that can navigate using the Oak-D-Lite. And so here you can see the Land Rover box in the foreground, and the name of our team is Midwest Defenders. It's Midwest because I live in Iowa, and Ted's kind of Midwest in Colorado, but we just called us the Midwest. It's close enough. And then Defender actually comes from the name of this Land Rover. If you look at the hood, you'll actually see it says Defender on it, because this is a Land Rover, and the name of the particular vehicle is Defender. I'm bringing up my notes here. So I started actually my assembly on November 23rd, and I finished on November 26th. To be clear, the competition actually didn't begin until January 1st, but I kind of felt like I wanted to get a head start and have the Legos actually built before the competition started. So I didn't do any work on the actual competition until January. I just kind of got the Lego vehicle ready in November and December. One thing that was fortuitous about that is the gift certificate we were given was for the Lego store, and unfortunately, the whole time of the contest until late March, the Defender wasn't actually available through Lego. So it was a good thing I decided to buy it through Amazon instead. So that was lucky. So after that, I started to, I have a bunch of different pictures here. Here you can start to see it really come together, the front and the rear. At this point, I still had like the clutch mechanism and everything in there, and the high and the low gear. And after testing it, I realized that I only needed high gear because low gear was incredibly slow, so it wasn't even really worth using. But here in the front, you can see where I put the electric motors in. Those are not part of the original vehicle. I actually downloaded a build where you could gave you instructions on how to add the Lego motors to it, and also a Lego servo for steering, but I ended up not using that design. Here you can see the motors a little bit more clearly. There was originally a plastic motor to go over this to make the hood, under the hood, look more like a real vehicle, but I decided not to include that, and I ended up using the space later on. So here we are getting close to complete, and here it is complete. So at this point, I completed it following instructions other than the motor and how the steering would work, so the steering could work via the servo instead. Then here's a good picture to show you exactly what's going on the inside. So we have a magnet here. You guys see my pointer? Oh, I went the wrong way on my slides. Just a second.
Yes, Jesse, we can see your point.
Okay. Lost my browser window for a second. Okay. You know how to go back in a spreadsheet? I'll just start here. Okay, there we go. Okay, so here we can see the magnet. This is a magnet, and this is a Hall effect sensor here where it says encoder. So that's actually a Traxxas RPM sensor that I like to use in all my builds. And then down here we have a standard 20 gram RC servo, and below that is a 3D printed bracket that I use to attach the servo to the Legos. And yes, I used screws instead of Legos because I didn't want it to go anywhere. So here we can see the battery now under the hood. So I use that extra space where the plastic motor would have been to hold a USB battery bank. On the left here, you can kind of start to see where I added some components internally to be able to mount the Pi and my microcontroller. And then on the right, you can see the Pi mounted just two-sided tape onto a 3D printed platform, the microcontroller board above that, and the USB battery above that. So here it is in the final form. On the left you can see the battery, then you can see the IMU dead center. Behind that you can see the microcontroller, and then the Pi behind that. So also here in the middle we have the Oak-D-Lite. I will mention the bracket for mounting the Oak-D-Lite is made out of ABS. The Oak-D-Lite does get very warm in use. I would recommend you have lots of airflow over it and do not enclose it, and keep those fins as clear as you can, and don't use PLA for a mounting bracket. I don't know if it could get warm enough to actually melt it, but I wouldn't take any chances. So here's another picture of the same configuration as before, where you can see the servo and the magnet. And then you can see here how the USB battery mounts in there, and the battery connector for the 9-volt. You can see the teensy in the upper right peeking out, and then one of these two USB power switches I'm using to actually turn on the Pi and the Oak-D-Lite. I do that so I don't have to unplug and replug everything in each time I use it. And now here we can see the other side. So at the very bottom you see the motor connector that goes to those two Lego motors. Speed controller, just really cheap speed controller above that. USB battery bank there again in the middle, the ESC switch and power switch. And the Oak-D-Lite has a one connect-in. The older Oak-Ds had like a separate power and data line, and Oak-D-Lite doesn't. But I'm using a USB power splitter for the power and data. And I really think I would recommend for anyone who's using these with a Pi to really, if you have any instability issues with the camera, just quits responding. Definitely add the power splitter. It definitely ran into some stability issues without it. Maybe they'll fix it, or maybe if you have a different setup to me, you won't require it, but I have needed it. And then again, the teensy. So after I completed the Lego build, I don't have a roof on it anymore. It just makes it easier to use, and I took off some of the other pieces of the rover that really were not needed. But here you can see I started to print some signs. These are designed to look like real street signs, so I made them as accurate as I could. Actually use images of real stop signs and other signs to print these, so if you look at them, they look very accurate. And then in front of those we have the tokens, which are actually 1.5-inch diameter poker chips that I'm using for markers for the road. Ted and I did have a discussion about what we wanted to do to indicate the road, and we thought about using some like pieces of paper and drawing lines on them, or maybe taped lines. And my problem with those was they require a lot of setup and take up a lot of room just for using those. So I instead came up with the idea of just using poker chips.
Right,
So,
and if I could add, Jesse, you can also
go
3D print the chips, and that works well. And I don't know if you're going to mention how you printed the signs on the actual printer. Maybe that's what you're doing here.
Yeah, I'll get into that, but in essence, the signs are two pieces: the base piece and then the upright piece are separate, and these just friction fit together. I tried different things, different size signs, and I came up with a sign that's around 1/12 scale, and the vehicle is around 1/10 and 1/12 scale, and so I just came up with a sign that would print easily on my machine. Then I took some effort to actually make sure to get the best possible image, and if you see at the very top left, you can see where I started with. The one on the right top was done with just regular paper with just the draft setting, and then the left was done, at the top left was done with like the high quality setting, and obviously that improved as well. Then the middle image here you see on the left, that's the same one as above, and then on the right, that's actually on real glossy photo paper, and that image came out really good. And then below that, you can see I actually did experiment with the one in the middle of applying a matte finish to the stop sign, the idea being to try to reduce glare. But it turned out it didn't look all that appealing, and I really haven't seen that much of a glare problem, knock on wood. Then on the right, in the big image, you can just see some of the different signs in my process. I did try different types of glue, like white glue did not stick very well to the ABS, even if it was like sanded, roughed up, the glue and the paper would not stick together. And I ended up using adhesive Gorilla Glue spray Gorilla Glue for it, and that seemed to work relatively well. Paper to plastic is always, unless you use some fancy adhesive, can always give you issues. And so then I just started taking pictures. When I say I took pictures of signs, I'm not kidding. I took literally hundreds of pictures. I think my number at the end was 300 pictures in total. But in each picture, I have multiple signs. So, I could have 10 signs in one picture. So the number of data points I have is considerably large. And if you look here, I have different backgrounds. I have different angles, slightly different lighting conditions because I switched the order of the signs, etc. So I really did try hard to get as many different variables out of the way. I did put the white background behind the signs just to make it a little easier, but not in all images. So then I did the same thing for markers. Here we can see all these different pictures of the marker chips at different angles, different lighting conditions. And then one thing that's important about training your images for AI is to have a null images. So it's images where you don't have anything to be detected. So that helps control for the negative situations where you don't want false positives for your detection. Make sure you always take, I was told like 1 to 5% of your images to be null images with nothing in it. That helps eliminate any background noise, etc., that could interfere with detection or come up as false positives. Then I built this little guy. On the left was my first attempt to build my little dude that I was going to use for collisions. You can see him next to an old Technic Lego guy next to the sign, and I thought his scale was not quite up to snuff, so I built this guy on the right. He's the guy that I was going to use for testing for an unknown obstacle to avoid. So this image is the very first time I actually got the detection working, and I was pretty excited to see it actually working for the first time. So I just have a picture of a picture, so it's kind of little low res, but you can see here it detects a sign with 99.9% certainty, and it gives you a XYZ coordinate to the sign. So it has both the depth and then a left and up to the location of the sign. So next, after acquiring all these signs, it's time to train. It's time to label the data first. So labeling the data is a very tedious task, and so I end up with 9 different types of objects. We have a stop sign, you turn right, you turn left, left turn, right turn, dead end, and no parking and reserved parking. So I have a total of 9 different objects that I'm trying to detect. So this is a program called Label Image, Label Im, that you can download and basically create a box around each object. You click, you drag it, and then you pick what type of object it is. If it's a left turn, right turn, whatever. And one thing to keep in mind is when you're labeling data, if you make a mistake, the AI isn't going to know or care, and you're going to end up with bad data. And I'll go into here in a little more detail about what algorithm I decided to use and why. But my 2 choices that I started with were either mobile SSD, MobileNet SSD, or YOLO. And I ended up going with YOLO. And I'll give you some more details on that. So I was doing this process manually offline. I was using that label image and imaging and creating all the labels. And it's a very tedious process. And I also had to create a data file for each image, combine them together into one data set, and pick which images I wanted to use for test data or you have 3 sets of data. You have your training data, you have your test data, and then you have your validation data. The training data is what you actually use to train the AI. The validation is what you use to confirm that the training data is good. And then the validation data is kind of like a last step to make sure that everything is working. And you do not want to train your AI on the validation or the test data, because you do not want the AI to be able to overtrain on those images, because that's one issue with AI, is that you can overfit the problem, and then it'll work great on your training data, but it won't work very well at all on actual real world data. So by separating your data into different groups, then you can prevent and measure that amount of overfitting. So I trained up a MobileNet SSD network using this data, and it was okay. A lot of times it would detect a sign, but it wouldn't know if it was a left sign, right turn, or a left turn, or a left U-turn, or right U-turn, and it wasn't all that good. Stop signs are one of the easiest things to detect because of their shape and color. Pretty much a stop sign is a stop sign. It's usually not. But if you look at the no parking sign and the reserved parking, especially when it's blurry like this, there could be a lot of confusion on which is which, and MobileNet SSD seemed to be having some problems. So I decided to switch over to YOLO v4 Lite. So in the process of doing this, I found a website called Roboflow, and I don't know if anyone here is familiar with them. But in essence, you can take those pre-tagged images and the tag data and upload it to Roboflow here. You just drop the annotations in the images here, or even videos. You upload a video, you can pick your frame rate of how many images per second or second per image, and it'll add those to your data set for training. So it's a really cool way of doing this automated. So they also have a UI for labeling and marking images. So you can go into that and create all these labels. So here you can see the stop sign is selected, and then I would go over here to the left and highlight stop and click on stop because it's actually a stop sign. And marker selected because that was the last thing selected before I switched to this image. So it was defaulting to marker.
Jesse,
yeah.
The samples I've seen so far, they seem to be pretty much straight on to the sign. Did you have some where the signs were more of a glancing angle?
If you look back here, you see some of these start to get, they're somewhat of a glancing angle. My theory was that would never be like totally off center on them. But if you look at the one at the upper right, that's kind of the angles I kind of supported out to that far, and middle one too. So there was some angles, but none of them were like really extreme.
Right, and we found out later on you don't really want to pick up on extreme angles because then it'll pick up on a sign on the side of the road that's not facing you.
Right, so in fact that still is an issue, and so what we found is you angle the signs in a way so they're not visible. It's a little trick we learned along the way.
So in that situation, did it key off the shape of the sign?
No, it could just quite see just enough pixels to figure out what it was.
Oh.
So you're talking like an angle of maybe just 10 degrees or something that it could see, but that was just enough to figure out that it was like a left turn or right turn or something.
Yeah, something like that.
Yeah.
It's a very shallow angle.
Yeah. So what I did next is I used Roboflow, and Roboflow has this option of training on the images and creating basically a neural network for you automatically. There's not a lot of documentation on what's behind that, but everything I've done up to now you can do for free with Roboflow. You can even do an export. You see this export button here. When you click on it, you can then do augmentation of your data. And so one thing I did here is, if you look, I had a total of 10 outputs per image. The limit normally is like 3, but I requested more and they gave it to me for free. They're quite friendly and they're really more interested in businesses. So for personal use, they'll give you a lot of free training, and you can work with them, and they're very friendly about that because they're just trying to get the word out there and get people to use their software. So for home users, they've been very friendly to me and helped me a lot in this process. So what I did is I changed the rotation between plus and minus 3 degrees, nothing extreme. The brightness between plus and minus 10%, and the exposure between plus and minus 10%, and then half a pixel of blur. What augmentation does is it makes subtle changes to your original images and adds it as another image to your set. So it basically is like a multiplier. So in this case, my multiplier is 10. So for every image I take, it creates 10 slightly different random versions of them. Not everyone's going to be minus plus 3 degrees. Some will be 1.5, some will be 0, some will be minus 2, etc. And the same thing with brightness, exposure, and blur. And this really provides a way of augmenting your data. So if I have 300 pictures, I can augment it, and I ended up with 3,000. So it's a really, augmentation is an important part of training for AI and fitting in neural network. Then I also resized all images to 512 by 320. And the reason I did that is because I want a certain scale of the sign, and 512 by 320 is the size I ended up determining to use on the Oak-D-Lite itself. So the main AI camera is a 4K camera on the Oak-D-Lite, but obviously if you're going to do AI on the full image, it's going to be much more intensive than if you do on a smaller sized image. And for the ranges, etc., that we're dealing with, which really are 4 meters and under, this resolution is fine. There's really no reason to use a higher resolution. But you're welcome to increase that, and it'll just decrease your frame rate some. So then when you select that export option, it gives you all these different types of data to how to export it. And so no matter what data set you're using, you could probably, what type of AI you're using, neural network you're using, you could probably find an option in here that will work for it. The mobile net was using the TensorFlow TF record, and I'm using YOLO darknet. So all I had to do is pick this, and then I could download my data with the images augmented and the marker data, label data, and it would split up between training and test and validation data all for me without any effort. So next thing to do is actually do the training of the neural network. So for that, I did it on my local PC, and basically I downloaded the darknet software and I compiled it and I ran it on my local machine. And you just let it churn for several hours, and when you get done, you'll get a data. So this is just some of what you'll see while it's running. You don't really need to necessarily interpret this. You just need to know. It'll tell you the MAP, which is kind of the accuracy. And I'll just describe that in more detail here in a second. So my recommendations for actually doing something like this is you're going to want Python. And I use Anaconda to give you a framework for Python for handling dependencies. I will send you guys the slide sheets, or these links at least, so you can follow along with me if you would like to try to do this yourself. But the second one is a Jupyter notebook that's out there on Colab from Google. If you're not aware of what Colab is, it's a service from Google where you can run Jupyter notebooks, which are basically like on the web programming notebooks, and you can actually use these for free, and they'll give you enough resources that you could actually do your training in this Jupyter notebook on the Colab for free. So you wouldn't necessarily have to have a high-end graphics card in your machine. You wouldn't have to set up your machine if you didn't want to. And you can also pay more through Google to get a higher end Colab CPU so you could do your training faster. I decided to use the darknet YOLO, which is available at this link, and the reason I decided to use that is because that's what that Jupyter notebook that was provided by Lexonis for Depth AI. So I decided to use that notebook as my starting point. But I basically took the code that was available on their website and see how it worked. I picked it apart so I could run it locally on my machine. So once you have your neural network trained, you have to actually convert it to be run on your Oak-D. You need what's called a blob. So there's a 3-step process that you need to go through for this conversion. The first step is to convert into a PB file, which is like a weight file that you have to export. And then the next step you need to do is convert from that PB into OpenVINO IR format. And then the third step is to take that IR file and then convert it actually into a blob file. All that is in the Jupyter notebook, and it goes through the process for you. It explains each of the steps. The main thing is this last step. What it does, it actually uploads your IR file to a server. It does its compilation, and then it actually it downloads the blob file and puts it in a certain folder, and then you can copy it wherever you want from there. So it's kind of a convoluted process, but once it's done, you have a blob file that you can actually then use on the Oak-D-Lite or one of the other Oak-Ds. What you'll see here is a window which shows the graph of the training rate. So MAP is basically how accurate it's doing on the test data. So you can see when it first starts off, it's not doing very good at all on the test data. But as it goes through it, the percentage goes up. And it goes up very quickly. So after only 3,600 iterations, somewhere around there, it's up to 85 to 89%. The recommended number of batches, which is number of times through each of your images, is recommended at 2,000 times the number of your labels. So in my case, it'd be 2,000 times 9 for a total of 18,000 batches. But if you look here, the percentage hardly changes after the first 3,600. And so if you keep going, you could end up overfitting the data. So if realistically, you could stop at 4,000 batches and not have to go through the full 18,000, and you're not really gaining much by going on. This is also an indication of how good your label data is and how well it's fitting. If your percentage is only like 60% and it levels out, then really you need to look at your data. From what I understand is most people say labeling and setting up your data is more important than what type of neural network you use. If you have good data, even if you have just an okay neural network, it'll work well. But if you have bad labeled data, it doesn't matter what you use, Bad data in, bad program out, basically, That's how it normally goes. Crap in, crap out. So I trained the neural network some, and now it's starting to get much better accuracy. If you see here, like with reserve parking and other things, now I'm getting 100% accuracy for stop signs, and left and turns are turning out really good. You will see here the one left turn behind it wasn't detected, and that's just because it's truncated too much by the signs in front of it. But that's not something I was really worried about. What I will tell you is there are a couple settings I'm not sure if I went over here in this document, but one thing I learned about YOLO is that it tries to also train with a mirror image. So if you have a left and right turn signs, it can end up getting very confused, and it'll never be able to differentiate between a left turn and a right turn or a U-turn. And there's actually a setting for YOLO that you need to set, says flip equals 0, so it won't actually try to train on the mirror image, so that it won't then get confused between left and right turns. I had a heck of an issue trying to get that to work correctly, but I really did want to have both left and right turns and U-turns working as well. So once I had the AI up and running, it was really time now to move on to actually programming the Pi and the Teensy. So the very first step was to actually get the two to be able to communicate. So Ted worked with me, and we created a library for sending data back and forth between the Pi and the Teensy. And if you see here, I send out data, I wait for it to be received back, and you can see it's right around 4 thousandths of a second, so 4 milliseconds between when it's sent and when it's replied back. So that means you could cut that in half, so it's taking around 2 milliseconds to send data to the Teensy. And I don't consider 2 thousandths of a second too much of a delay to worry about. I will tell you, going forward, I'm switching from a Teensy 3.2 to 4, and one of the reasons is to decrease this delay, but also increase my throughput rate. So going forward, I will likely be using a Teensy 4 instead of a 3.2. After I had the communication, then it was time to actually write the programs for the two of these. And I will mention, I'm skipping over a lot of details about this, but I have a detailed 3,000 word write-up on the project, and I go into more detail about a lot of these things, so you're more than welcome to look at them and ask questions based off of that. So I created this curses-based UI, so it's basically just a text-based UI. The reason I did that is because it's very fast to send over a network, and there's basically no delay. Whereas if you have a graphical UI that you're sending over a network, it's going to be slow. So by just sending text, you can get very fast data. And it doesn't even have to redraw the whole screen. It can literally move to a certain line and just draw data on that line using old school terminal TTY commands. So it's really old school technology that most of your young people have probably even never heard of. But what this does is it shows you it's the Midwest Defender Control Program. Next, it shows you how many packets have been sent, how many have been received, how many were valid, how many were invalid, and then finally the time since the last data was received. Then here you can start to see some of the commands, like to change modes like stop mode, manual mode, auto mode. Then you start to see data, what mode it's currently in, what the command is being sent to the TNC from the Pi, or what the TNC is deciding to do, input from a joystick, the XYZ location of the rover and the heading of the rover. And below there you can see things such as showing or hiding the camera image, showing the depth data, display what the neural network is doing, take an image, record a video, reset the current location, hide this list if you just don't want to see it, refresh the screen, etc. So this just gives you a way of debugging it. So showing the camera image, of course, is slow because it's transferring so much data. Long term, I'll probably create like a web streaming app to view the camera image rather than what I'm doing now, which is just transfer it manually through MOBA Xterm. So it's just a X11 window, more or less. Maybe something like BNC would be more appropriate, or doing like an actual MPEG based compression and showing a video stream. So I'll probably switch to something like that in the future. And then down below we have a bunch of lines here that'll tell you what the last issues were. What it's saying here is control manual cannot be monitored because it wasn't quite set up and I didn't have a joystick plugged in, so the initialization failed for the joystick. And the current mode is stop. And then at the bottom it says you can press uppercase Q to quit the program. So it's just a very quick and dirty way of controlling your rover and doing it through a network connection, but with very low bandwidth. So when you're actually in the UI, this is a camera view. So here we can see what the camera sees. You can see a stop sign and a left turn, and I removed the left-right data, but I kept the depth. Here you can see that sign's 1.1 meters away, and then on the right, the left turn sign's a little further away. And then for the markers, I just put a box around them. I don't provide any data. It just shows you where they're at, and it knows internally where they are. Here's actually a recorded path. So what I did is I let the rover navigate, and I just took the dead reckoning coordinates from the rover and I plotted them. So this is actually a trip around my house, and I actually will show you the video of this later, and I have a special surprise coming. But here you can see the actual path it navigated. I tried to include the marker data into this, but I was unable to make that work. There was an issue there with finding exactly where the waypoints were, where the markers were, and try to overlay the data. There was enough noise in that data. I've so far been unable to put the markers or the signs on this map yet, but it's something I might try to work on in the future, so you can then look at the results of a navigation. So while testing this, I did run into some problems, and what you can see here is I ended up having to glue one of the drive shafts in the front of the vehicle. It kept coming out of its connection, so I tried a little white glue just to try to keep that joint from failing as often. So it's like a gear drive shaft interaction, and the drive shaft would just slip off the gear. And it turned out this white glue did not work, which turned out to be a good thing because I actually put it in the front axle front connection backwards, so I had to take it back out. But luckily, I've since actually super glued that connection, and it's not coming apart again. I don't like gluing Legos, but there are times when it is necessary. There's some other parts of this rover which was not really designed for navigation for real that I would suggest you glue if you're going to use this long term. So along the way, I was like, how do I detect obstacles that the AI doesn't recognize? And I came up with the idea of using the depth camera from the Oak-D. But if you try doing that, it's really difficult. I worked for quite a while on that towards the very end of the competition and trying to figure out a way of interpreting that depth map data. But it's noisy, there's outliers you have to remove, etc. So what you can see here is, what I did is I took the depth map and I converted it into a point cloud. You should very clearly see the outline of my hand. Now this is actually taken from above. So what you see around that is actually more or less the lack of data, or as you would call it, a shadow from the image, because my hand was above the sensor and above the sensor was the ceiling. So the data couldn't be seen for the depth map around my hand because it was blocked. And all those points, as you can see, are more or less flat because it's a ceiling. So I thought it was really interesting that I was able to take the depth map and convert it into a point cloud, and with enough accuracy actually be able to see my hand. So it would suggest you should be able to reduce the resolution of the depth map, convert it into a point cloud, and then interpret that point cloud to look for obstacles. You guys still there?
Yep.
Jesse, can you expand on that? Why the depth map is less useful than the point cloud?
Yes, I was going to take some images to show you, but after we do this, I'll expand on that in more detail. I'm actually gonna, my surprise is I'm gonna do a live demo, and I will actually in there enable the depth map so you can see it.
Cool, thanks.
Yep. So that is the end of my major presentation on the Oak-D. I will of course go over your questions at the end, but we're going to do a live demo now. And as many of you know, when it comes to live demos, they're very risky. So I'm going to step out for just a second. I'm going to turn the rover on, and I'll be right back. In the meantime, I'm still here if you have any questions.
What a journey, huh? And Ted, Ted, you've got your own copy of one?
Yeah, so we each made a copy. So this is my copy. And yeah, you can see it's kind of packed with electronics there and a lot of USB cables.
Nice.
Batteries.
So
Anyways, yeah, it's a pretty good size for a Lego kit.
Yeah, I looked at a lot of the different Lego kits, and this was the one that seemed to have the most space available. And I thought the name was also clever. It's called the Lego Land Rover Rover. So it's LLRR is the name I normally use for it. So it's the Lego Land Rover Rover. So I just thought that was kind of a cool name. And we were given a total of $400 per team, and it just so happens each rover was around $200 a piece. So we ended up having just the right amount of money. If it wasn't for the fact the Lego store couldn't be used because it wasn't available there. Yeah.
Hey, the reason, or I'm assuming the reason why the depth map wasn't useful is just too many points to look at. The data is very noisy. It's also hard to interpret where the ground starts and what is actual obscured, what is really a blocked image. It's very hard to interpret that data. I've tried, and maybe somebody smarter than me could do it, or just somebody has more time. But I had approximately 2 weeks to do that before the contest ended, so I didn't want to spend any more time on it. It was just. And honestly, when I tell you what I'm doing next, you'll understand a little bit more why I decided to move on.
That seems like Kareem's problem that he kept talking about when he was using a depth camera. You might want to, next time Kareem is on, you might want to ask him what his experiences were.
Yep, so I'm going to switch to sharing a different window now. I'm going to share my terminal window for a second here. So what you'll see here now is I'm using a program called MOBA Xterm, and it's really a cool, it's kind of like combining like PuTTY and X11 server and all these other things you're used to using into one congruent UI. Ted uses this as well, and I'm sure others do. If you haven't ever heard of it and you do any interaction between multiple machines like Windows and Linux, it's really amazing. So I really recommend it. And for personal use, for home use, it'll say down here below unregistered, but it's free for home use. They don't care. You don't have to purchase it. And then, like I said, Ted will tell you he likes it a lot too.
Yep. Exactly. It's great.
So I just type my login in a Pi, and it remembers my password, so I don't even have to type it. And it can even detect my previous PuTTY session, so I don't even have to import it into here. It just works. So here we have a prompt on my Raspberry Pi. This is live and in person, so if I type a command, it actually runs. So now we're going to go into my rover, and this is it's sitting in my hallway right now. And here you're gonna see an actual copy of that same UI that I showed you earlier with the curses UI. But now this is live. So what you're seeing here is the time since the last data was received. You're seeing your frames per second from the camera. You're seeing the actual position of the rover, etc. And again, as you see here, it says the joystick subsystem failed because I do not have a joystick on this, and I have no RC control of this, I promise you. So here you can just see it'll just sit here forever unless I do something. So what you don't see right now is that there's actually another screen I have up that I'm about to share with you, and there you'll see you actually see the video of the rover itself. Just a second. Okay, so now you should be having another screen coming up here. Let me know when you see it.
We're seeing it.
There it is.
Yep. This is my living room, and this is live. This is going on right now, so I'll go step in front of the camera just to show you. That's live and in person right now. So this is set up in my house. I have a course set up around, and we're actually going to try to go for a little drive. Any odds on if this is going to work or not?
I think it'll work.
Oh yeah. Oh yeah.
I'm a little nervous because of my test runs this morning. 2 out of 5 failed. So we will see. And I'll explain why they failed afterwards. So we're getting ready to go in 3, 2, 1, go. It'll take a little bit. The refresh rate isn't all that great, but I'm sending uncompressed images to the network to my machine and then sharing it to you guys. So I apologize for the frame rate, but I think you'll get the idea.
Are they like 4K images, Jesse?
This is actually 1080.
AP.
I'm scaling it down. I'm actually taking the 520 image I'm using. Oh, well, we have a failure. I'll go get it and we'll try again. I'm gonna turn off a couple lights too.
I wouldn't have known that was a failure if you hadn't told us, Jesse.
Well,
You're supposed to drive into the wall.
Yeah. It seems it may have possibly detected a turn sign. That's a new failure mode. So what I'll have to do is take some more null images of my environment so that it doesn't detect the null, the false images. So we're going to give it just another go here. We're reset up. I don't need to reset the position or the rover of anything or the heading because it's all relative. And I'll go into detail also how the navigation works.
Yeah, it may have interpreted those as like a U-turn or left turn, the scroll.
It would have been a right turn, it determined.
Oh, right turn, yeah.
There is a right turn straight ahead, but you can see I have it angled so the camera can't see it. And I have it hidden with a box as well. There we go.
Yeah, and you can see it picking up a few of those markers.
Yeah. And I'll go into details about the algorithm. Oh, come on. Oh, that's why those boxes are there. Wouldn't you know, today is the day where everything goes quote-unquote right.
Demo effect.
Yes. I'm very familiar with the demo effect.
A few weeks ago, I had it driving all around my kitchen consistently every time, no problems.
Yep, me too. One thing is, I actually have mirror training data that I've been working on in this, but again, this was enough for proof of concept for the contest, and honestly, I'm surprised it's doing this. It is very much the one thing that could be wrong is that I actually scaled up the image to show you guys, and I think that has a negative impact on the frame rate for actually using the camera. So we're just gonna go again. We're gonna keep going until it finally makes it around, or we run out of time, or you guys get bored.
That's a 2 out of 5, right?
Right.
One more failure and you're due for 2 good ones.
If this one doesn't work, I may try reducing the frame rate and trying again. One funny thing is, if you look right when it turns this corner, to the left there's a stairway, which is currently enclosed. When I was doing one of these tests, it accidentally detected one of those signs that we were talking about. And as a result of that, it tried going down the stairs. And for a Lego rover, that's a pretty bad. You know what? I think the glare is affecting it. It looks like it's glare from the sun. So I will try to remedy that.
Well, Jesse, is it working now on higher resolution pictures than it was trained on?
No. It's actually, all I'm doing is scaling up the image that you guys see.
So that's just slowing down the bandwidth.
Yeah. So it's just the processor is doing too many things at once. And if the frame rate drops too low, it might miss a marker. So I'm going to make some lighting changes here, and we'll try it again. But that's the reason why those boxes are there, because that section to there often gives me issues. So I made a couple of lighting changes, turned off the lights, closed the blind, and it's still running. So I'll just show it this. It's trying to navigate still, so now I will show it the stop sign, make it stop, and start again.
Yeah, it's kind of a cool way to turn it off. You just show it a stop sign.
You can hold one in your hand as well. It would have the same impact.
So you got the gesture-based UI.
Yeah.
Stop!
Flashcards.
I had an idea originally of like giving a set of commands like go this distance, turn left, turn right, etc., and use signs to do it. So you could do a run just by showing like flashcards to it or something.
Yeah, that'd be cool.
But that doesn't really help us with the challenge for what we're supposed to do, something based off of industry and manufacturing. I know I'm stretching a little bit. Oh, I think it's gonna make it this time. Yep. So I closed the blind, and I also turned off a light in the kitchen.
And one
So
thing,
now
those turn signs, it's based on distance when
Yep.
it turns.
So when it gets a certain distance from the sign, it turns. It's 0.9 meters. So if you see there, it actually detected it as a stop sign for a second, but as it gets closer, it's really certain, and now it's turning. And now it's coming back down the hallway, back down to me. And it's gonna stop at 1.1 meters from the stop sign, so it'd be a 1.08 or 9 when it actually stops. You'll see it. I'm very confident on that. Oh, 1 meter exactly, almost 99 centimeters. So it depends on the speed a little bit, where it ends up stopping. But again, that's live. That is real and in person. I'm just gonna shut it off here, and I'll bring it with me.
Well, Jesse, because we understand how hard real and in-person demos are, that's why we have gold stars.
Thank you. I'm planning to.
Still seems like with OpenCV, lighting is everything. You know, if you don't control it very well, it doesn't work very well.
Well, if you work on your AI as well and you do more training with null images over your varying light conditions, I think you can handle that relatively well. but it's a very difficult challenge.
Do you think it would be easier to control, to try to do some pre-processing on the image intensity?
Well, here's the deal. It's running on the Oak-D. The AI is actually running on the Oak-D. Excuse me. And I'm not sure if there's any way to do that processing there. I'm not sure what's available for pre-processing the image. So my Pi doesn't have enough power actually to run the neural network I'm running. It's running on the Oak-D at a very high frame rate. It can run as high as 30 frames per second. And it's just getting the data back that's the bottleneck there, what we're seeing right now. So I'm going to go back to my presentation, and we will continue. So I guess I get a passing grade then on the demo.
Absolutely.
I'm a little more nervous about Thursday, where I'll have a much bigger audience for that. So we'll see how that goes.
Well, you can tell them that you've already gotten a gold star.
Thank you. So I have links here to the video and the final write-up, which is around 3,000 words. And I'm going to, this is my backup plan if for some reason the live demo didn't work. This is the actual presentation video that I gave to the group. It's approximately 5 minutes long, if you guys don't mind.
Sure.
Please do.
So this is what I gave to the Luxonis and OpenCV group for the competition. And you'll see 3 different scenarios where I ran. Here we go. You guys hear any audio or not?
We don't get the audio.
Okay. Which is unfortunate, but because I actually spent quite a bit of time working on the audio portion as well, but we'll just go with the video. So this is Ted's rover navigating at his house. So he set up a course, and I'll let him speak if he wants about what he did.
Yeah, so it's kind of tight going around my kitchen, but it's doing fine. And I have a minimal amount of markers there just to keep it centered. One thing we noticed was the sometimes the depth information, if there's nothing behind it, it won't actually pick up the sign. So that's why I put a box behind that one. And the other thing to notice is this is the autofocus Oak-D-Lite, and you can see it gets out of focus a lot. It's not a very good option. The fixed focus is a lot better.
My recommendation there is for rovers, the vibration also can cause issues with the AI. So this is a previous video of a very similar route. You can see my wife was here at the time playing Fallout on her PlayStation. But here you can see this is a higher frame rate because this was recorded and then played back. It's still a bit jerky because it's still interpreting the images and save it to a micro SD card. So it's still not quite as good as you could get. You can actually get a compressed MPEG video stream directly from the camera, and that could be 4K and it could be very high quality. But I haven't figured out how to draw the markers on those images, so I just picked this way of doing it instead of just saving individual images and then converting them into a video afterwards. So you can see here I made that turn just fine. One of the reasons for the signs was that turn was actually too tight for the rover to navigate using markers because they're off to the side of the screen of the camera, so it would never be able to pick them up. And you'll see here right around 3 meters out, oh, right turn, left turn, no. It doesn't really do anything with the sign until it gets close enough, so it doesn't matter if it's a left turn or right turn, it doesn't really care. And then I switched to a view so you can see it actually navigating and headed towards the stop sign. And again, it will stop on cue like it's supposed to. Now this was done out of MakerSpace locally here where I had more room to operate. But what you can see here is I didn't even have a marker in between. It just aims for the sign and then makes a right turn and just keeps going. It overshot the turn a little bit, but as you can see, it corrected and got right back on track. Now down here at the end, I have a U-turn, so it's going to detect a U-turn, and the way I coded the U-turn is it's actually 2 turns, so it's 2 90-degree turns, and I did that because internally the teensy basically just is given a heading to travel and a speed, and so if I gave it a 180-degree turn, it could decide to turn left or right. It wouldn't know which way to turn. It would pick whatever route was quickest. So it wouldn't turn a left turn. Now, this is a continuation. This is not a new video. This is the same video. It keeps starting up exactly where you saw it. And now we're doing it on board. And now it's going to keep doing a right turn. You can see it gets a little closer than I prefer. But it picks up the markers and just keeps going. And now I speed this up. This is to show you a long run. This is to show you consistency, and how it just keeps going and going and going. And as long as you have a little control of your light situation, and this was indoors, at the place where I had full control of the light, and you can see it just keeps going. Yes, there's little false markers there off to the left, a bit of the torn bit of the carpet, but it's still chugging along. So what happens now is it keeps going, and we keep seeing, and it keeps doing this route. But what happened is when its camera's away from the view, what I did is I switched out the sign. So now instead of a U-turn, it's got a right turn. This is showing that it is dynamic and that it's not recording, like doing a pre-recorded route. Now it's going to turn to the right, and we have markers out here in the distance, and it's going to just pick them up and just keep going. So it just picks those up and just keeps navigating on.
Jesse, is it just trying to keep those chips in the center of the...
Right, but it's a little more tricky than just looking at the closest chip. What it does is it looks for multiple chips. So if it finds 2 chips, it goes to average between the 2. It goes in between the 2 of them. If it only sees once, it just keeps it centered.
Gotcha.
I use the distance to the chip and the x-axis, so the distance left and right, and it's just arctangent too. And I use that angle and I add it to the current heading, and that's how I aim for the chips.
Gotcha.
That's literally all it does. It's just an arctangent. The whole control algorithm is ATAN2. That's it. So that's really, to me, that was really impressive that that's all it took. Originally, I was trying to do a PID controller on like the X distance, but it took into no account the distance away from the marker, and it was just very unreliable because that X distance changes over how far away it is. So that control algorithm worked horribly. And then when I went to the ATAN, the first thing I did was just look for the closest chip. And well, it was herky-jerky all the way to the left, the right. The steering was very unstable. But when I started saying, if you see 1 chip, just aim for it. But if you see 2 chips, aim for the distance, a point in between the 2. If you see 3 chips, aim for a point between the second and the third chip. And what that does is means when I'm turning a corner, it kind of acts like a look-ahead distance. Because as my boss says, you can't really look right where you're at right now. You can only look where you're going. So if you look at the closest chip, it couldn't make very tight turns at all. So by adding code to detect beyond 1 chip, I was able to get it to turn relatively tight radiuses and do so in a controlled and straightforward manner.
Cool.
Jesse, did you have the fixed focus or the autofocus on yours?
I have the fixed focus. The focus is only matters only for the 4K camera. The depth cameras are always fixed focus. So we're clear. All right. So, what am I doing next? Anyone know what this is?
Big.
It's a very cool vehicle.
This is a Indy autonomous car. This is the real deal. These raced last year at Indy and this year at Vegas. So last year at Indy, they were going to do a challenge. It's called the Indy Autonomous Challenge. And the idea is to have real, these are Indy-like cars raced around the Indianapolis track. And they had to avoid obstacles like barriers or inflatable stuff that was put out in front of them. And this was a time trial based test where it was based off your lap performance. So it's like your average speed over 3 laps. And it was a cold day. The track had rained the day before, so traction was not all that good on the track. They had done some testing of side-by-side racing because that's what they really wanted to do. But unfortunately, they just weren't confident enough in the systems to do that. So it turned into more of a time trials format. I'm not going to go through the whole competition, but it came down to really 3 cars in the finals. 1 car did okay. 2nd car was pretty good. Then the 3rd car was fast. It was hauling. It was doing like 160 miles an hour average around the track. Unfortunately, the final competition, instead of being 3 laps, was 5. But they only did 4 laps. And so it slowed down after the 4th lap, and they lost just because they forgot to add 1 to the lap count. Oops. They lost $700,000 because they forgot to add 1.
So are these electric vehicles or are they
These are gas powered. They have a professional team of racers who maintain them for you. So they started them up. They get everything warmed up for you. All you have to do is use electronics. There's 3 Lidar cameras up here, 3D Lidar cameras. There's Rtk GPS. There's one here. There's one on the other side. They use a professional drive-by-wire system that was provided to the teams. They have radio communications. They have like the e-stops you can see. They have real-time communications, like very high bandwidth provided by Cisco. So these things are legit. Each one of these cars cost over $1 million. So they had like 10 or 12 of them there. 8 teams actually competed. So this is, in fact, from USCD. This is actually the same car, electronics, on a go-kart. So this has everything that the big cars have, except the Lidar was a little smaller. But it's otherwise, electronically, it's identical to those big cars. Now,
did the other ones use a real high-end GPS Rtk? Because the ones that we would buy are maybe 10 hertz or so.
Yeah, but
speeds,
Novatel and places like that have much higher RTK rates. I believe you can get as much as 100 hertz.
Yeah.
I wasn't going to mention it, but now that you brought it up, there were a lot of GPS issues at the event. In fact, most of the crashes and issues at the event were caused by GPS failures. Car spun out in the infield, car hit the wall. Another one brushed the wall and was all because they lost GPS lock. Indy track has these huge grandstands, and so right around the front straightaway, it's kind of a canyon effect for GPS. And I wonder if it's just not a good location for the Rtk GPS. They did it at Vegas, and as far as I know, they didn't have any of those issues. And at Vegas, they actually did side-by-side racing and passing, and that was awesome. I didn't get to see that in person, but I was there for this one. So what am I doing next? Well, I'm not ready to race an Indy car, but I can do my best to pretend. So what we have here is this really amazing low-cost 2D LiDAR sensor. It's called an LD06 LiDAR sensor on the left upper. You can see how small it is and how easily it mounted to the front of my rover. down below that. And then on the right, you can see I put a little protected box around it so when the rover isn't being used, I can keep it from getting damaged. And then on the upper right, you can see what's called a TF Luna. It's a very small I2C based Lidar sensor that you can change the address of. So you could have multiple of these on your vehicle. So you could have 3 of them on the front, 2 on the sides, or however you want to set that up to have a very, and they're pretty low cost, like I believe $20 or under, especially if you buy them in bulk. Yep, that's the one.
So what's the cost of the LiDAR, Jesse?
The LiDAR the normal cost is $150, and they're actually available for $130 right now. It is 10 revolutions per second, 4,500 points per second. So you get 450 points per second, per rotation, and at 10 revolutions a second. That's pretty good for $130. I mean, it's an amazing sensor. The asterisk is I've tested it and it works great. I don't know the long-term durability, and that is one issue with low-cost lidars. The old ones would use like metal contacts that would rotate, and over time they would just fail. And so they work great when you first get them, but somewhere between say 10 hours and 100 hours they would just fail, and that was the end of it. But supposedly this uses something like the RP lidars where it's actually wireless communication and wireless data or power or something. So hopefully it lasts. But as for a low-cost entry point for doing LiDAR, hey, I don't think you can beat it. And I moved on though. This is a high-end Hyoku UST10LX. Retail OEM price is $1,600 for that LiDAR unit. I went over this last year during my presentation. I have not paid $1,500 for this. I haven't paid $1,000 for it. I have 3 of these, and I didn't even pay $500 a piece for them. Basically, they're used in many commercial purposes, and they show up on eBay. People either don't know what they are, or they just want to sell them, and you can often get them pretty cheap. And now that I've said that, I probably won't be able to find one again because one of you guys is going to buy them. But I placed an auction on a UST20LX, which has twice the range of this one. I was going to win it for $250, but I think the person realized it was worth more than that, and they canceled the auction before it ended. I asked them what happened, and they gave me some story about they sold it locally. Yeah, right. How many garage sales are you going to go to and just find one of these sitting there and buy it? Not likely. It actually works through Ethernet, and it requires 12 volts. So what I did is I bought a USB 5 volt to 12 volt booster, and it's relatively inexpensive. It was under $10, and this thing only requires 450 milliamps of power. So that USB booster was plenty good enough to make it work. So, why am I doing this? Here's what that LiDAR can provide you. If you look at the image on the left, you can see a box that is 16 centimeters wide from 4.3 meters away. It's very clearly recognizable as being a object there, and this LiDAR is impressive enough. This high-end LiDAR does 40 revolutions per second, and it gives you around like 1,000 points per scan or something like that. So we're talking much higher resolution, much higher quality. So you can see here the box and how many pixels I have on that box. It's 4 meters away. And then you can even see it's the same hallway I was just running in. You can actually see the doors. You can actually see the door frames, and you can see just that couple inches of the inset of the door. You can see it. You can clearly see it. So I was very impressed by this. And so that box is, at 16 centimeters, that's not a lot. So it sees it very well. Well, the image on the right, what is that? At the very top, you see an object. The red means it detected something, but it's so far away, it can't draw it on screen. So that means there's a wall or a couch or something back there, but it can't render it. But what you can see here is there's a traffic cone. That is our DPRG special 18-inch traffic cone 5.5 meters away, and clearly it can see it. So I think you can guess where I'm going with that. If you didn't, here's the same thing, but 1.5 meters away. Now you can see it's a round traffic cone.
Now this is with the high-end
Yes.
Hokum.
Yep. Yep. So here at 1.5 meters away, you can clearly see it's a traffic cone. I mean, it's round. I mean, you combine this with, say, image recognition from somebody that may have some experience with an Oak-D-Lite, for instance, and I think you can understand where, if you guys, why I'm interested if you guys are going to do Robo Columbus in this area. And if I promise you, if I win this competition for the Lego contest, I will. It weighs like 80 pounds. So I am going to use what I was motivated by at the Indy Autonomous Challenge, and I've decided to race in Formula 110. Formula 110 is basically done by universities as a way of providing competition for autonomous vehicles. It was started originally approximately 10 years ago by MIT, and it's now grown into a competition by multiple universities. For years, they've had this competition, but it always said you had to be a university. I finally decided to say, hey, I'm an individual and I'd like to race. Can I? They said, sure, go ahead, come on. It's a bit intimidating, and I'll explain. Competition is the last week of May, right before Memorial Day, and I just finished the Lego competition. So these are all the things I have to be ready to get done before then if I would like to compete and have a chance. Simultaneous localization and mapping, SLAM. I have to be able to use the Lidar data and create a map of the environment and use that map then to locate where I am, which is called Monte Carlo localization or particle filter localization. So that's using the map data and what you see from the Lidar and correlating the two. I have peer pursuit path following code already, but I need to take that code and actually put it onto this rover. That's like half an hour of work. That's not a big deal. I need a simulator to simulate the rover driving around, slipping, speed issues through corners, and emulate the LiDAR data so that I can have an accurate simulation for recreating the maps. Then introduce errors into that to see if the localization issues I'll have with my dead reckoning can help, will offset that error, etc. Or how do I do that? Is there some way for me to use the Oak-D in this competition? And I have some ideas about that, but since I am in a competition, I'm not willing to share them right now. Let's just say the rules state that your rover has to have a box of a certain size on the back of it, but it doesn't say what material it has to be made of, so I can't go by color or even by shape because there's no defined way of detecting the box with the Oak-D-Lite. So I have some other ideas I'm going to try. Again, sorry competitors if you're watching this, I'm not helping you out. I need to parameterize my code so that I can make easy modifications. I can change the top speed, I can change the cornering speed, etc. So I need to add parameters support to my code. During qualification, you'll do laps at a certain speed, and based off those speeds, you'll get your pairing for the races. And along the way, though, you have to show that you're able to avoid obstacles, static and dynamic obstacles. So when your rover's going down the back straightaway, they'll throw a box in front of it, hopefully far enough away that you can avoid it. But they're of a certain size which they define, which is, I think the thinnest is like 35 centimeters, so twice the size of the box I can see from over 4 meters away. So I should be able to come up with some type of algorithm to be able to detect those obstacles and avoid them. And I've done work with A-Star and R-Star and A-Star Plus in the past, so combining between a pure pursuit and then some type of either that or MPC control algorithm to be able to avoid the boxes. If some of these terms you're not familiar with, I understand it. There's a lot to this, and I have less than 2 months to do it. So I'm going to build a second rover. If you look behind me, you'll see there's two of them back there, one with the Lidar and then one that's still in pieces. Because in the racing, you're actually going to be up against the other rover, and you start staggered. So you start half a lap apart, and you have 10 laps, and the one that's completes the laps is the fastest wins. So because you start staggered, there's a chance if you're half a lap faster than the other person by 10 laps, you're going to need to pass. I kind of had ideas, you just follow if you got half a lap ahead, you just follow the other racer until the end of the race. But there's always a chance they could crash, or you could crash. So I'm not sure it's the best idea to just hang out behind the other rover and let them continue on.
Hey, Jesse?
Yeah.
Are you doing the virtual version or the in-person version?
In person.
Okay, that's good, because I just noticed the virtual, one of the teams is called Team Crash a Lot. So...
And the final challenge, if all this was not enough for me, is I need to create an optimized path for racing and figure out how I'm going to handle passing. And this is all May 23rd through 26th in Philadelphia. They shared a picture of the floor. It's shiny concrete. I can't think of a worse surface to race on. There's a total of 28 teams registered for the physical event. And if you look at the teams that are registered, it's hilarious because you'll see next to my name, it says personal hobby. All the other ones are prestigious universities.
Well, that's even a stronger reason why you should win.
I'm also not using their software stack. They have an existing open source raw space stack that any team can take, make some minor tweaks to, and race. I'm creating everything from scratch. All the work I did for the Lego contest, which I didn't cover a lot of it, but I created a whole framework from scratch that's a ROS-like framework with sub-modules and classes and all kinds of stuff that I just didn't have time to go over today. And I go over that in some detail in the write-up. But here you can see the surface. I don't know about you, but I can't think of a worse surface for racing on than that. The only thing that would be worse is if it was wet. So, what am I going to do with all this after this race, if I do it? What does that look like? That is an electric go-kart that I've been working on, you know, between everything else. It's a kids go-kart. It's designed for kids 5 to 7. It's hefty. I mean, it weighs close to 100 pounds. But I've got a big, huge servo on it. The servo is just incredibly large. Then I have a ammo can for my batteries, and I have a 3 or 4 horsepower brushless electric motor on it. I have in fact driven it via remote control. I'm using a VASC speed controller on it, and I need to do some work on the timing and the startup sequence for the motor. It's a little challenging. I've been trying to do it without sensors, and I'm just going to add a brush sensor to it because that motor does in fact have sensors. And so rather than trying to figure out how to get it work without sensors, I'm just going to add the sensors, and it'll probably work a lot better. But like I said, I have driven it just at low speeds, and I have to give it kind of a little kick to get it going. So if you think my little 1/10 RC scale cars are scary, this guy is, when it's going, is just going to be insane. And this is our
special
project.
go-kart parts. I'd recommend Go Power Sports. They're a Texas company.
Yeah, I've done a lot of research on different parts. There is actually a go-kart racing series that's done at Indy, and they have a very specific chassis they want you to use, and batteries and motors, because they want it to be more about the algorithm than the go-kart. It's not about who can make a fast go-kart. It's about who can create, using the same hardware to create something that operates the best. So it's about software, not hardware. That's really the goal of F110 as well. It's one reason why I'm using a Slash instead of something more fast, like a Fortec, which Traxxas has, like an on-road vehicle. Something like a Slash isn't really your best platform for going fast. It's designed more for off-road and stuff like that. So this is electric lawnmower I started on. You can see I have two geared motors, yellow jacket motors in the back of it. The height is adjustable, so you can adjust the right height, the mower height. Then on the front, I got curious about wheels. Well, if you look at most of these riding mowers, the autonomous mowers, they have like a third wheel that like pivots, like a caster wheel. And I decided to try something different. And I don't know if these wheels are going to work or they're going to get jammed up with grass when they'll dry, but I'm trying them out just as something different. So we'll see. One thing that I found amusing in that picture on the left, you see that black bag there? It was full of sand to weigh down the front of the mower, so the mower didn't tip over when you were just let it be. It's so lightweight in the front that they had to add all that weight to the front of it just to... I guess it would feel cheaper too, because that was like weighed as much as the rest of the mower almost.
So you didn't add that bag of sand? That comes from the factory?
Yeah. Yeah. I was quite amused by that. Once I take that out, it's a great place for my batteries and my electronics. I didn't share it, but I have a picture of it. There's a lot of room in there for stuff. It actually is going to work out amazing. So I'm going to use the Lidar data and perhaps Rtk GPS on it and be able to navigate that way.
So what mower base was that from?
This is a Works mower. Let's see if I look it up real quick. Works electric. I picked it up locally for about $100, and it had basically never been used. It's a Works 40 volt 14-inch cordless lawnmower. So it's nothing fancy.
So is it like available at Lowe's or Home Depot?
Yeah.
Or...
Yeah.
One of those.
My plan is I was going to actually sell the batteries that came with it, and basically the mower would be free then because of how much I paid for the mower. So it's only $100 with the 2 batteries and charger. I could basically resell those and do it basically for what I paid for it. So I'd have a free mower to work with. So I appreciate you guys, and I'll stay here and answer any questions. But same as last year, I have a 10% discount code for SparkFun. It's good on any SparkFun original items. It's good through the end of the year, one-time use per person, but you are free to use it however you wish. Discount.
Jesse, thank you very much.
Yeah, cool. Discount there is Jesse B2022.
Cool.
Thank you, Jesse.
By the way, thank you. I was a little hesitant to show you the guys, the rover of the video of the rover running, because I was gonna save that for when you guys did another video competition. But as you can tell, I think I might be able to come up with something better with what I have planned right now.
Looks like you've got some options at least.
Yeah. Being my daytime job is I do real-time simulation efforts, and so creating my own little Formula 1 10th simulator should not really be too much work. I'm actually going to use, they have a simulator for Formula 1 10th, but it's really designed for Ross, and so I'm going to take the simulation code for the rover, which is not that much code, and I'm going to use that to create that. And they even provide code for simulating a Lidar, so I'll probably integrate that code into my existing simulator, which is just a bicycle model vehicle. So you just know the wheelbase, and it's one wheelbase. It's not like Ackerman steering or anything like that, but it's more than appropriate for doing low resolution offline simulations for something like this. Any other questions?
Bravo, Jesse. Thank you for sharing.
Thank you. I will provide a link both to the write-up for the contest and also for the slides for this if there's some links in there you'd like to explore more.
Really great. Thank you.
Yeah,
Thank
Jesse, do you have
I'm
any?
crossing my fingers here that coming April 21st, I get the good news that I won. For you guys who want, I will be again giving a similar presentation to the OpenCV group on Thursday. It says OpenCV weekly webinar. I only have 40 minutes there, so I won't be going into nearly the depth. The only good thing is the competition is now officially in the judging phase, and I can somewhat present my case for winning by giving some information during that presentation. So.
Jesse, can you send those links to the mailing list?
Sure can.
That'd be great.
Yeah.
Yeah.
And
No problem.
Jesse, you have no problem with me putting those links in the DPRG write-up about this? Okay.
Nope. Nope. Nothing I provide is in any way an issue. On this presentation, though, I was kind of hesitant to reveal anything before the competition was over. I didn't want to give anyone any ideas what we were doing.
Mm-hmm.
I found around 10 videos from this. If you look for Spatial AI or OpenCV on YouTube, there's approximately 10 teams that I found videos for out of the 50. So I don't know if the other teams did not create a video or if they're on a different platform or if they're hidden. So I currently know of approximately 10 competitors for this competition and what they've done. So.
How do they look to you? What do you think? Feel good?
I'm confident, but I'm not going to be overconfident. I hope we do well, but it all depends on the judges and what they think. One interesting competitor is this thing called Poke Yoke, which is basically you have 6 bins, and it's detecting if you're putting your hands in the wrong bin, and then you show to the camera what objects you have, and it counts them, so it knows that you have the right number of objects for the assembly. Then it shows in the assembly if you put it where it needs to put the parts in, and it'll tell you if you have it right or wrong. So it helps you guide you through the assembly stage. And I was impressed, but I've done a little more investigation. He's been doing that for years, so he just took what he was already doing. So I'm a little less impressed. He didn't do it uniquely for this contest. And then there's a guy who used the camera for monitoring sourdough. So it's watching the sourdough to see if it's rising or falling or whatever, and when it has an issue, it'll tell you that you need to add more sugar or whatever else you need to do with it. So I thought that was kind of interesting. And there's several, I don't want to speak badly of any competitor because they're all great, but less enthusiastic presentations, let's say. So we'll see. I mean, at the end of the day, I don't see their write-ups. All I see is their presentation videos, so I don't know what detail they went into and explain what they did, etc. And to me, that's just as important, if not more. Cool. Which is how I end up at 3,000 words. Those will be split up and available at SparkFun as blog posts in the future as well. And also a big shout out to Roboflow because they gave me help along the way, and anyone who's interested in doing AI should really look at Roboflow, at least the way of getting your training data set up. And that export from there is completely free.
Carl, excuse me, Jesse, you put that link in the chat?
Yeah, I found the Roboflow link and put that in as well. A link to Darknet YOLO, the Lego Land Rover Defender, MOBA Xterm, MOBA Tech, a couple other things too. The Lidars you found. So lots of good links in there, Jesse. Thanks.
Yeah, no problem. Like I said, now that I told you guys about those Lidars, I'm not sure I'm going to get as many of them cheaply now, but I have bought the last one. I have 3 of those. The last one I only paid $250 for because I have 3, so I have 2 primary ones for my cars and 1 backup. Then I have a 30-meter version, which is the UST 30LX, and I have the extended range version EW. I'll let you do a little sticker on that shock on that if you look it up. It's a $5,000 unit, and I paid less than $500 for it, and it works.
Well, if you follow that curve on out, you should be getting them for free very shortly.
Unfortunately, I think we kind of bottomed out on that curve. But if you guys are familiar with Rtk GPS, what's been happening there is just amazing. Like I have this facet from SparkFun. It's a survey grade Rtk GPS for $600. The antenna's built in. It's got Bluetooth for data. It's got built-in everything. I mean, it's quite amazing. And then you can hook it up through serial, and this could become your base station, and then you could have a mobile unit for doing, say, a certain cone challenge. Again, you could use it for doing Rtk GPS in that challenge.
And it's only $600 plus, right?
Well, you can get the individual Rtk GPS units just in modules, like the little red boards, for under $300, and those are SparkFun original, so you can actually get 10% off on them. And then you can get an antenna for around $60. So if you have correction data available locally, like I happen to, there's a local Department of Transportation office, which is like 3 miles away, and they provide the Rtk correction data for free throughout all of Iowa. Wherever there's a DOT office, they provide the correction data for everyone who wants to use it free, no charge.
We don't have that where I live.
Yeah. There are some things available in Colorado, at least, because I had thought about using Rtk GPS at the SparkFun ABC in the past, and I did find some. There's also many commercial availability, so you don't necessarily have to spend the money on an expensive base unit. But if you use one of the Rtk modules and say $100 antenna, so you could really have a good two-station Rtk GPS unit with a base and a rover for say $500 to $600.
Yeah, there's a lower end module. I bought 2 of the units so I could do the base rover setup. And, I bought the less accurate, but it's down to 2 centimeters, which is incredible. You know, I think the other one is
one key I'll mention is it's really good to have a dual band Rtk if you can afford it. It gives you much quicker acquisition times, and it is also better with multi-path errors, etc. when you have dual bands. But yeah, you're right. The lower end, there are units which are cheaper, but my base entry point now is dual band. And sooner or later, we'll have the new L5 GPS units available, which is going to completely blow away everything else out there when that's available. I've heard rumors that a good L5 chip should have the same accuracy, and the units will be in volume $30, so a breakout board might cost $100 for those when they come out.
Wow.
So the GPS technology is on that curve. It's going down significantly. And 3D LiDAR, 2D LiDAR, even millimeter wave radar is getting pretty impressive as well. All right, guys, thank you.
Thank you, Jesse. Very good. So that concludes our meeting for the day. If anyone would like to hang around and chat, that's fine. But once again, Jesse, thanks very much. Gold star. Way to go. Live demo. Good luck on the 21st, dude. We're with you.
Thank you.
Yep.
And Ted, too. Good.
So who's going to stick around? I got you.
There's a bunch of us here. I don't have anything to say. I'm just going to hang online while I compile the meeting notes and get them over to Doug.
Okay. Yeah, I accidentally got kicked out of the meeting, so I lost all of my chat notes. So if you could please, Carl, make sure I get the chat notes.
I have snagged them. I got to tell you, Jesse, this and Ted, you guys have gotten me jealous with all that you've been doing, but I have this year been a little distracted, so I'm going to be spending time for a while now on restoring a 57 Mercedes 190 SL.
Yeah.
Sounds like fun.
So, going old school.
Yeah.
I spent 3 months hardcore working on this project. There was not a lot of time off for me.
Yeah, I have to say, Jesse did most of the work. Life kind of got in the way for me, so I did not contribute a lot to this other than building a rover and running it.
But I appreciate our discussions. That, of course, was appropriate and helped out for some motivation along the way, too. I took a week off from work to work on this, and that week I put in 60 hours on this. I think estimated I have between 200 and 250 hours total into this project.
Month and a half. Yeah, almost.
Yeah, in 3 months.
Right.
So,
The day
but
job. That's a lot of desk time.
Yes, pretty much my entire weekends and 2 hours each day during the week. And then, that week as well. And my efforts now for Formula 1 10th are even more. The only way I'm going to make it is to do that level of hard again. I can't keep it up. So I'm really not sure if I'm going to be competing at Formula 1 10th or not. It's in Philadelphia too, so I'd have to drive all the way out there and get a hotel and everything, and no cost. But I've been told, however, if I have a vehicle ready to run, I may have a sponsorship. So I'm trying to get done. Roboflow is a very interesting company, and it's funny because I actually met a guy locally from Roboflow. It's a company based out of California, so I didn't think I'd ever meet anyone. And hey, I live like 5 miles from you. Oh, okay. So I actually met him in person. The one complaint I had about the Oak-D-Lite was that stupid power splitter. I needed it with my Raspberry Pi to make it work. They have them available on the Oak-D website, and they're if you have the Kickstarter link, they're only $10. If you don't have the Kickstarter link, they're $20. But shipping's $50 because it's overseas, and all the shipping options are not available because of COVID. So the only options you had for shipping was $50. So I spent $10 an item, and I had to spend $50 to get it shipped. So I actually talked to the OpenCV, and I'm like, hey, can you send me one? And they just can't send me the same link. And I talked to that guy from Roboflow, and he's like, I'll get them for you. I said, really? So I had 3 of them show up. Because I sent one to Ted because I was afraid we were going to need it. Do you use it, Ted?
Oh yeah, it wouldn't work without it.
Yeah. So when we did the Kickstarter, it was an option whether you bought it or not. Because I was part of the Kickstarter, and that's actually how I found out about the competition. And I assumed I needed them, so I bought 2 of them with the Kickstarter, and I sent one to Ted. So I only had one. So I was afraid going forward if I had any failures with the Lego project or something, because they're a little fragile. So I was really afraid I was going to lose the only one I had. So now I have 3 spares. So.
Yeah, they're just little things.
Yeah. And the bottom of it bends really easily.
What is it?
If you have cables connected to it and you move it around at all, you can snap it right off.
Yeah, so it's got 2 going in and 1 going out.
Okay.
So one of them's for data and one's for power going in.
Isn't there, I think there's a, or is it so? I thought that there was a generic version of those that you could do, like a USB-C splitter.
There is, I've seen them, but I've seen like disclaimers on them. They're only for very specific uses, and they're not guaranteed to work. And with the $150 camera, I didn't want to take too much of a chance of those not working. I have seen them, but like they're far in between, and they basically like it may or may not work. So I just wasn't willing to take that challenge. But anyone else who has them is welcome to try and see if they smoke the camera or not. I wasn't willing to do that.
It'd be nice to figure out what they're actually doing.
Yeah, I think they're just splitting off the power lines, and I don't think the other one has the power lines, the 5 volt or whatever connected. USB-C is a little weird though, because like when you get into it, like there's this communication standard for turning on power bricks and like voltage and current regulation. So I don't know if they're doing any of that stuff or not.
Yeah.
But USB-C, it starts to get a little more tricky with the USB 3 and power requirements. There's communication that happens. The days of the resistors to tell what you want are over with.
Yeah.
Well, I mean, the cables themselves, the cables that have active electronics.
Yeah.
The capability of the cable, they say, like, I'm a cable that's only good for power. I don't carry data.
Yeah, I
I
hate
know
those.
because I got cables like that.
Yeah, I hate that. Yeah.
This one looks interesting because, like, their USB-C, I don't know, I'm just throwing this out there, but like this one I found on Amazon, it's a hub. It's meant as a hub, so it'd be interesting.
Yeah, I saw that. I saw there's some other ones out there too.
Yeah.
The only thing is, how do you power it? And try to power it on my little rover is, well, that has HDMI on it, so that's definitely a little more than I'd want. But yeah, I looked at powered USB hubs and that. But again, I'm trying to keep the weight of my rover down. Most of the competitors in Formula 1 tents are using NVIDIA, like higher end NVIDIA Xaviers and that. But they're unobtainium right now, unless you want to spend $1,500 or $400 units going for a markup of 3 or 4 times just because of the market conditions.
Yeah.
I didn't want to spend that, so I asked them if I could use the Pi 4 instead, and they said that was fine, but it means my computation resources are way less than what my competitors have. Yeah.
So
Jesse,
Jesse,
something like MPC, where you try to simulate the rover in real time to decide what angles for steering or avoiding obstacles. I got my work cut out for me if that's going to even work.
hey Jesse,
So the cable from Lexonis works, and Ted, does the one that you have work as well?
Yeah, he has the Lexonis one as well. I sent him. Yeah.
Oh, that one is okay.
Okay, so Jesse, on the there's two things. There's two symbols. One is the USB symbol, and the other one is the
power.
Yeah, power. So you're just plugging that into a 5 volt USB-C power brick, and the other one is going into your Raspberry Pi.
My Pi. Yeah.
Okay. All right.
And if
now,
you try powering the Pi directly off of it, it'll sometimes it'll work, and after like 5 minutes it'll drop out.
Yeah. Now I noticed.
Unplug it and plug it back in.
I noticed on Ted's rover, he had. It looked like you had 16. What is it? 16.550s. You didn't. Otherwise, you didn't have the USB brick. What do you?
No, I do have the brick in there. Mine was just in a little different location. Let's see if I can show it here without dumping stuff out. Kind of taking mine apart.
Oh, okay.
But this is the brick right
here.
here.
I got it. Okay. All right.
I haven't decided if I'm taking mine apart yet. It depends. If I win the $5,000 award, I'll probably keep my rover together. But otherwise, I will be taking my Pi and net out for my second of my F-110 rovers.
Yeah. So, hey, Ted, Jesse, what brick are you using? I'm just curious, because I think I've got a couple of them.
I originally was using an Anchor.
Okay.
But I'm actually gone to this one from SparkFun. It's called Unicell. You see it? It's called Unicell.
Okay.
And it's got 2 USB-A ports and a USB-C port on it as well.
Yeah. Okay.
And I really like that one. It works really well. The problem I had with the Anchor is it only had one regular USB-A port on it.
Yeah,
and due to how I have my electronics set up, it didn't work very well.
But you haven't had a problem, Ted, right? So you must be wired slightly different.
No, I'm wired pretty much the same. It's just I was able to get everything hooked up, I guess.
Okay.
You're probably not using the USB-C switch like I am, though, right? You're probably just directly wiring it in.
Correct. Yeah, directly wired in.
The switch wouldn't work because it doesn't transfer the data line, so there's no way for the power brick to know what was going on. So it's like one of those situations you're talking about where it's a power only cable. So I couldn't use the USB switch like I am, and I just, especially on my race rover, I didn't want to have to plug and unplug everything every time on my race rover. It's just got two switches, like on the side here. It's just got the switch. I just push this button and it turns it on. Then here's the one for the Oak-D-Lite right here. So I just push this one and turn that one on. So if you look here, I have a nice big heat sink on there for my Pi. And then I have the Oak-D. I'm not sure about the Oak-D if I'm going to use it or the position of it. I just got the Lidar working. What I have learned is with those 2D lidars, the angles of the Lidar are so important. Otherwise, you're looking at ground. Because if you have any slope to your Lidar at all, at some distance out, it just sees ground. And so I have to work on that angle to get the best view from the Lidar. And the difference between what I have and what I need is only 3 degrees, but it makes all the difference in the world.
I guess
I ought to go up a little bit further than I need, so that when I'm slowing down in the corner or something, it won't nosedive enough to end up seeing the ground. It's trickier than I thought it was going to be.
Jesse, I've run into that same problem with the sonars on the outdoor robot, and I ended up fixing that by driving their position with a servo, which was driven from the IMU.
Yeah, I thought about a similar solution. I'm trying to avoid it because of the whole KISS approach, but it's in consideration. I don't think any of the other teams do it. I think they put sensors up high enough in the angle, especially with not a good view. But again, I'm trying to do things out of the box than they are.
Well, is seeing the ground out ahead of you necessarily a bad thing?
No, but you need to see it at least far enough ahead to see the corners, and because I'm trying to use SLAM, the more data I can get out of the Lidar to know where I'm at, the better. Yeah, if you have a long straightaway, it'd be nice to know the corners coming up so we can go down for it. So it was seen at about 3 meters out, and realistically, I'd really like to get the full 10 meters out of the Lidar unit. So it is what it is. I mean, if I can't get it working, but it's just an angle issue, so it's solvable.
Jesse, there's one thing.
Oh, go ahead.
I was going to say, there's one thing when you were talking about your arctangent deal with the dots.
Yeah.
So that's remarkably similar to the first one I did with that complex line following course. Really terrible electromechanics setup, but the algorithm, it found line segments and it kind of deduced where, based on where the line segments were, where it should be aiming, and then it used basically the angle and the length of the distance in the scene from the like the nose of the robot to the point, the angle and the distance to figure out how big of an impulse to take and at what angle. And it was so it was a very low sample rate, like 1 or 2 samples a second maybe, but it was effective. So it was neat to see that you found a similar thing.
Yeah,
in a way, even though you were looking at dots, not line segments.
The TC itself, all it knows is its current heading and the desired heading. So it does the actual steering, and part of that is because the Pi is running not running real time. I can't communicate constantly. So the TC is responsible for actually driving the rover, and it has a PID loop. It's like a PI loop for the speed. But right now it's a very dumb algorithm because it just starts at a certain speed. It just slowly increments it till it hits that speed and slowly decreases it. So it's not appropriate for my F110, but for what I was doing with the Lego, it's more than appropriate. Yeah. All I'm going to do differently for that, for the F110, is create a lookup table when it's free running and say, oh, this start at this throttle value for each 0, 10, 5, 20, whatever miles an hour, and create a table that I can interpolate in between for a starting speed. so I don't have to ramp up my PID or anything. I can just say, start here, this is what it is when it's running free. Yes, you'll probably have to add, and maybe I can figure out some adjustment factor, some scaling factor to add. So say, well, if it's this free running, it would be this, and just start from that throttle position. So, but obviously, like I said, the F-110 is so much more of a challenge. But I'm up for it. It might be next year before I'm racing though. And they hold these events all over across the world, so I'll probably wait till they have another one in the US. I know there's one coming up, I don't know if it's next year or the year after in Texas. So the ICRA, which is the host event for this, is coming to Texas. So I'm guessing I'll certainly let you know more when I hear it. I just heard that at one of their meetings that they were coming there. So maybe I'll have to come to that one and I can show you guys my rover in person then.
Yeah.
And we can come too, and we can cheer you on.
Yeah. Hey,
well,
Jess.
If you're there, you're going to be a more active role than that. I'm going to need help.
So we could also trash talk your competitor.
I don't know how that would go over with college students. Just think about that for a minute.
So Jesse, how do they outline the course on that?
They are using laundry or like dryer vents, so they're like 6 inches in diameter. They have 2 of them stacked on top of each other.
Huh.
So they're just using those flexible laundry outlets, you know, that you would hook up to your dryer. So they're just using those.
There's vertical posts.
Across the whole course, then they have a laser cut support beam that takes the 2 of them, so they end up. So you have a wall a foot tall around the whole course.
Okay.
And the course can be up to 100 feet long by 30 feet wide. 30 meters by 10, but I've been trying to find a space to test, and it's harder than you think.
Yeah.
My garage isn't big enough. I found a makerspace that they have a couple rooms they're not using, and so long as I join the makers, that they've said I could use it because they don't have any use for it right now. So I actually have a space available. It's all, the walls are all turned up, there's no carpet on it. It's not quite as slick as what I need, but it's the best analog I have so far for it. So I gotta get slam marking. I really need to have slam marking by next week. End of next weekend I need to have slam marking or I'm in trouble.
Oh boy.
Well, I'm gonna use like something like Breezy Slam or something existing. I'm not gonna try to do it from scratch. And the other thing is I'm hoping my dead reckoning on my rovers is always really good, and I can have accuracy of less than, over the length of this course. If I'm going slow, I should have an accuracy under 6 inches to a foot. So I hope I can have less of those closing issues for the loop than I would otherwise. And I have some tricky ideas how I can maybe use the Oak-D for positioning around the track if I can set up some markers so I can avoid some of that. I don't know. I don't know. I have other less reasonable, more questionable ideas that may work as well, but I have to go through all of them and just see what does work. Again, that's why I need to have it working by next weekend though. But I'm taking next week I'm taking, the week after this one I should say, I'm taking that off to work on this. So I have another 60-hour-a-week challenge to work on this.
Yowza. That's hardcore, man.
Like I said, I can't keep doing this forever. The second this Formula 1 10th is over, I'm taking a break. My wife will want that as well. So every weekend she's like, "What do you do?" You know, I just kind of look at her like, "You really have to ask?" How's the weather down there?
Right now, gorgeous. Yeah.
Gorgeous. We had a picnic.
Yeah, we're like in the 50s. It's a little cool here. It's not all that great.
You keep having these Sharknadoes.
Oh my.
This is what it's looking like outside there.
Oh, that's
Trees are starting to bloom.
Yeah.
we had a bit of snow on the ground yesterday. It snowed a little.
Cold in the morning, but it gets up to 80s.
It's 84 right now.
Here's one of my little signs. Dead end.
Dead end.
Yeah. I never ended up using that one. I was originally going to stop at the stop signs and then go, so pause and go, and I ended up just using it as a stop sign, so I never ended up using the end. So I have a bunch of label data I end up never using, but because 9 labels, it seems like a little, but it's actually a lot. And I never got around to using my little guy, my 3D printed.
So did you hand label each of those 9 signs in each of 300? Oh my goodness. Oh my goodness.
Yeah, one thing that Roboflow has is that you can train it, but it costs money unless you can get some free credits for it. And then use that to automatically label the data. So you say label data and it'll just go through, and the ones it recognizes, it'll label it for you automatically. I just found it wasn't all that reliable. Roboflow also just came up with the option now where you can assign people to label the data. So I upload the data and say, okay, it's available, and a group of people can go out there and I'll label it for you. So I actually had the guy Mohammed from Roboflow. He actually labeled some of the data for me. I uploaded it, or we drove the rover around with his camera from his phone, like taped in front of my rover, and we drove around and took video, and then he annotated all those for me. So like I said, this guy from Roboflow really has helped me out quite a bit.
That's wild.
Yeah, it was funny. I made a Roboflow account, and I was kind of asking them how to do stuff, and this guy Mohammed says, well, what are you doing this for? And I said, oh, this contest. And he says, oh, really? I'm talking to this other guy who's doing that same contest. It turns out it was Jesse.
By the way, this guy is named Justin DeWay.
Justin what?
Justin DeWay.
DeWay. Very good.
Love it.
So I even had like a resume for him and everything, but since I didn't use him in the contest, I didn't put that into his bio for the competition.
Jesse, if you saw Paul's talk a few months ago, where they were doing the big it's big military.
Yeah, I was there for that one.
Yeah, you may remember that they had a Justin Way that were basically mounted on carts. And when the vehicles would come by, they'd jerk a rope and jerk it out in front.
Yep.
All they wanted to do to see, can you recognize that this is a person and stop?
Yep, yeah. I've seen some pretty scary demos. Yeah, I've seen some pretty scary demos of that being represented. And the other one is the semis, like coming up on cars, and the car just suddenly stops, and then the semi has to like autonomously come to a stop behind the car. It's like, I don't want to be in that car. It is scary.
Well, I gotta head, folks.
Yeah. I gotta do some work
I
here.
think it's time for me to go.
Yeah,
Thanks again.
thank you, everyone.
Ted, good to see you all. Donna, Will, Lucille, we'll catch you all later. Have a good
Good luck.
weekend.
Good luck,
Yeah.
Jesse.
Hey,
Thank you. Bye.
yes. Yep. Bye-bye.